if it doesn't fit the constructor's needs, you can run it through the program and we'll help you do the efficiency calculations. We also have our retrofit program, so that's an existing building.
Can you hear now? Yes. Sure? Yeah. Okay. We're back. People online, I apologize for that. Hopefully it's been resolved. So now we're going to talk about the types of benchmarking. There's two main categories it falls into. Either you're doing a benchmarking of a building that doesn't exist yet, or you're doing a benchmarking of a building that does exist. So pre-design versus post-design. Benchmarking a digital model provides estimates for energy intensity or consumption. So when we look at the impact of a digital model, the perspective of it is we're looking at lighting or HVAC or envelope, and as it relates to the fixture type, lumens per watt, control system. So how detailed you want it to be, whether you want occupancy sensors and photo controls, how many, how often, as well as the type of control, how granular you want that system to be. All those things affect how much energy savings that will have, or energy efficiency on your building. And so you can look at that ahead of time and estimate. That doesn't guarantee that's what's going to happen and what's going to get built, but you know that's what it should be. And so it's centered around what if. So what if we use a different model? What if we use a central control system rather than having each system be individual and isolated from each other? What if we increase the window to wall ratio for the south facade? What does that do to our solar heat coefficient? Is it worth it for getting that extra daylight for the photo controls for saving the energy versus the investment we're going to have to make into the window and the envelope? The other side that you're also probably familiar with is the retrofits or renovations. So again, that's buildings that existed, and the impact of that. Here at the IDL, we kind of look at three different contexts: as designed, how the building should perform; as built, how the building is performing right now; and then as used, how is the building being used? Has it been repurposed? Has the actual retrofit taken place, or have they just decided to change the use type without making any actual changes to the infrastructure of the building? All those kind of affect energy performance and occupant satisfaction. And typically, the way the questions of those are posed are, where do we start? So here at the lab, we recommend doing a tiered economic approach, as well as creating a roadmap or energy goals, something long-term that could be referenced and brought up again and again. EnergyStar kind of defines it into two other groups, internal and external. So this deals more with data analysis. So the internal allows energy managers to compare energy use of buildings or group buildings to profiles in the organization. So this is more common for manufacturing, or if you're managing a lot of large commercial properties or real estate of that nature. You kind of want to have a portfolio of it, and you can reference it and see. You can add it to your, theoretically, your score or the intrinsic value of a property by considering its energy performance. Because you can extrapolate how much that's going to cost based off of kilowatt hours and the price index of energy. External is probably what you're more familiar with, and that's the whole EnergyStar score or LEED certification verification, the shiny plaque you need to put on the side of a building. It's more just to compare and show off, but also to see what others in your industry or sector are going to be doing and how you stack up against them. So either way, it facilitates energy accounting by comparing buildings' energy use to similar buildings to determine opportunities for improvement, or verifying energy efficiency measures by quantifying savings. The last part is really important and crucial to present to your client. Energy efficiency measures by quantifying savings. So that means you can hold it in your hand, you can measure it, you can give it to them, and they will know what to do with it. I'm going to quickly go through some of the history of benchmarking. The beginning of energy efficiency, as we consider it today, began in the 70s from the era of oil embargo. The original catchphrase, so to speak, what they were trying to market it as, was conservation, not energy efficiency, because it was kind of dealing with the whole broad spectrum. It wasn't really focused on the buildings or cars or appliances. It was more of like, let's throw stuff at the wall and see what sticks. So here's some interesting policies. I'm not going to go into depth, but you can look at the video later or ask me for the slides and you can see this. But in 1975, the Energy Policy and Conservation Act was created, which gave us the first field standards and standards for household appliances, and actually creating a baseline and determining how much energy they use or should use. 1977, the Department of Energy is created, the Department of Energy Organization Act. Another key thing is ASE, the Alliance to Save Energy. You can think of this as a think tank for conservation or energy efficiency that was created by two senators to help also create the Department of Energy. But more importantly, what happened in the 70s during this time is this policy, which required utilities to purchase power from independent power producers at avoided costs as compared to creating a new power plant or produce supply to meet demand. So what that meant was you needed more energy. You had to justify the creation of a new energy source when you could readily purchase that power from someone else on the grid. So it's not, one of the ideas was we are producing enough energy, we're just not using it smartly. So it's there, we just need to allocate it In the 80s, it also took off. ASE doing a lot of policy, a lot of development, a lot of paper on trying to get the public on board. So one of the best ones they did, though, in my opinion, and we still use a version of this today, is a private sector financing technique for energy efficiency projects. So incentivizing the private sector to utility groups by giving them tax breaks and incentives that they can pass off to their customers and organizations. And then that also got handed down to the states individually to determine what's best for their state. So, and then the late 90s, what concerns us for this lecture today is the Environmental Protection Agency created EnergyStar, which we use still today. So, and then lastly, there is one I would like to show you. I'm not going to go over the 2000s because that is all very recent history. Okay, but I do want to show you this gem that I found. Oh, it is not playing, nothing's going right. So basically, this is a commercial that was created for energy efficiency by EnergyStar, and this family decided to have a static electricity powerhouse. So everything like just friction, rubbing, generating current. It's pretty funny, and so like he's trying to have him heat the water for a hot shower. So this came out in 2001. I thought it was absolutely great. Take a look at it. Sorry about the sound. Still having technical difficulties, but we'll get through it. So it's called the Static Electricity House PSA. If you want to look at it, show some of the friends. But let's talk about where to start for benchmarking. So an overview, you need to determine the type of benchmarking you will be pursuing, either internal or external. Is this a pre-design or an existing building? So that's going to affect the software and the type of data and the amount of data you're going to need to collect. Develop a plan. You want to set goals, define scope, develop data requirements, and communicate with necessary parties. And then, of course, the most important part, implementing the plan. So collecting data, doing site visit, analyzing that data, so evaluate the benchmark data and results. So starting with the plan, start with a plan that includes the following: setting goals. So what type of benchmark are you trying to pursue? Is there a performance percentage baseline? Are you just trying to figure out where you exist in the ballpark and where you need to go? Determine the scope of work. So it's a level 1, 2, or 3, and that kind of determines the detail of the analysis, how much data you're willing to collect. Identify the data needed. So this varies site to site depending on the building you're using. So if you're using a school, you're going to want to look at, do they have a stadium for sports, the gymnasium, auditorium, theater, and then because it's a school, you want to keep in mind of office equipment, because while that is minor, when you apply it to a school, almost every single room has that type of equipment, if not more. So then it exceeds the margin of error and it has to be accounted for because it's using so much energy. And lastly, make sure you engage with partners, building owners, facility managers, office managers. Let people know why you're there so they'll leave you alone, but also so they don't get freaked out if you come ask them questions about a building or operation or things of that nature. And so this is kind of some common benchmark types. You have a best in class, looking for a performance goal. Like I said, you're just looking to establish a baseline. You just want to know where you're at. If you want to try to get above average, so there's a certain EnergyStar score or profile average that you know or that are aware from CVEX, and you want to just be slightly above that. Commission or national ratings, so that deals with LEED certification and EnergyStar certification. So the EPA, they define it in 2 ways. So there's energy performance, which is exactly as I said, based on energy use calculated across different types of buildings. The difference with energy performance and energy performance ratings is that the ratings use statistical algorithms from CVEX data to compare it of similar buildings, type, size, and usage. So take it with a grain of salt, the energy performance. And then some buildings you have to use the first one, you can't use the rating system because there's just not enough data available. So that's also why it's good to build up an internal profile so that you have that data available for yourself. If you want to learn more about either of those, here, some links for you. It's just on EnergyStar.gov. So let's talk about goals. Are you trying to achieve an overall understanding of the building performance? Is there a particular issue with the building that needs to be investigated, i.e. there's a series of higher utility bills than normal? Are building occupants complaining about lighting, air quality, or noise, temperature, something's gone wrong? We'll definitely let you know. So the last two are common things that we get at the lab, which is we have secured funding for building upgrades, either equipment or entire systems. Where do we start? So benchmarking is a good way to figure that out. Or they've already determined that they are going to do it, and they want to know what will have the most impact on the energy profile, while keeping the most cost effective. Generally, that's where that one's more applicable to municipalities. They're on a budget and they have to have proof of concept so they can continue to do it and continue the upgrades. So a lot of that, we're going to shift gears now into actually going and conducting the benchmark. So data, we're going to go over some tips and tricks. You want to collect as much data as you can before you go to the site. So before you go to the site, try to secure floor plans, mechanical plans, zoning and control schemes, operating hours with anomalies. Are they holding a drill once a month on a Saturday? Is there an employee training session that happens, every other quarter, or things like that? You want to establish, again, connections with personnel, so facilities managers, building operators, building owners. You want to keep them informed and up to date. And you never know who that one guy is who's been managing the building for so long and he knows where everything is and can tell you anything you want to know about the building. That is a valuable resource if you can find it. Also, before you go, you can identify energy hotspots. So servers, pools, auditoriums or theaters, radio or communication rooms, things of that nature. Those are things you're going to have to hit, so you can prepare for them. Multiple site visits may be required, and that's okay. You want to identify data tiers of collection. So at the lab, kind of how we organize it is documentation is one of them. So a nameplate or equipment ID. So often RTU or a heat pump or AC unit. And then you have verifiable. So that means we're bringing loggers out, plug load, light meter, air quality, CO2 meters, things of that nature. We're collecting the data that we're going to use and reference. And then there's also inferred. So general information is fine because you can eventually find it on the web, or what EnergyStar and AHSRAE have done is they compiled a list of just common things. So like a 55-inch LED TV. You can input that into EnergyStar and it will do it on the back end, figure it out, and how much energy it's going to be using. And then typical operating, you'll pull that from the operating data you've inputted, or that you pull it to assume as a default. Then lastly, divide and conquer. Having multiple people for the site visit is always great. Makes it go faster and you're not taking up or disturbing the building occupants' time more than what is necessary. You want to assign roles, so have someone be assigned to lighting, someone dealing with the HVAC, someone cataloging office equipment, as well as miscellaneous equipment, refrigerators, ice makers, vending machines, things of that nature. And then lastly, what I recommend, and we have some of these resources for you, you can just email us or pull them off our website. Just checklists, inventory lists, questionnaires, things to just use to bring to site. So you're just filling things out and it's already formatted in a way that you can easily input it into a digital system, either Excel, EnergyStar, or an AHSRAE Excel sheet, etc. And then lastly, before everyone leaves, check in with each other, figure out what data you actually got, what problems people are going to have, so you can see if you can get that data real quick before you leave, or if it's necessary to plan an additional site visit. So something about data, there is such thing as too much data. So the higher level of data you collect will improve the accuracy of your energy audit because it's more accurate. However, the trade-off is the time and resources it takes to process and analyze that data. That actually go out and collect it and then process, analyze. So my mentality, how I approach it is I always try to document it to big fish. So things I know, like if I know a lighting system is complex fluorescence, and it's at least 5,000 square feet, I'm like that's going to be a serious category of energy use for that building. Also looking at HVAC, their HVAC was done in the 80s and it hasn't been retrofit, or the retrofits have only been bare bones minimum to keep the doors open. That's going to be an issue. I believe that's what having the personal connections, relationships, talking to people will get you. So now we're going to get into you've actually collected the data, you've done that, you have the data available in front of you. What are you going to do with it? So we have EnergyStar and AIA. Left the AHSRAE off of here because, well, it's pretty common what they have their own standards, their own formulas, and they have their own best practices workflow. So we don't really need to go over that so much. But EnergyStar is a program run by the US EPA that promotes energy efficiency. Portfolio Manager is what we're interested in today. Is an interactive resource management tool that enables you to benchmark building use of any type. And then AIA came out with their own. So the key difference between the two is EnergyStar is meant for anyone to be able to use because anyone can be a building owner. AIA's DDX, Data Design Exchange, is specifically designed for architecture and engineering firms to track their commitment and progress to 2030, but also so they can see where other firms in their region, state, or area, how they're performing, where they stack up. But also AIA gets all your data, and they can look at it and see what policies or incentives they need to give out to start pushing people even further on what they need to do. They're both very intuitive on how to use and use. There's plenty of how-to guides and step-by-step and videos that each organization has developed. So I was planning on doing a portion of this online with it, but given how technology is reacting right now, we're not going to go that far in, so I'm just going to show you the slides. But if you are interested in learning EnergyStar or integrating into your firm's process, we do have a program, Technical Design Assistance, and that is one of the services we offer with that. So if you're interested in having us teach it to your firm, having the one person or a handful of people being able to use it, it's always a great asset to offer. So when you're using either one, there's data required and data optional. And for data required, most of the fields, they have a default value that you can use as a placeholder until you collect it. So you don't need all the data. That's why I say you go back and do multiple site visits, and you're just going to refine the energy benchmarking over time. If you're lucky, you'll get it done once. And so there are also, like I said, handouts and things you can take to the site. So here's a Word document, and it's basically the exact same information that you're inputting here, you're documenting here. So it's a one-to-one transfer. It's really easy to document the data and input it for upload. So in this example, every time you fill out a field, the next one's going to populate or give you options. So in this one, we're doing a K-12 school. It's one single building, and then there's three types of status you can have: existing and design, as we talked about. So a building that does exist and one that you're thinking about building. And then this one that was my favorite because I got to play around with it is test property. So that's where you can basically just rate the things. What's the min? What's the max? How does it affect it? What's the impact going to be? Just doing a ton of what-if scenarios that you know. So it's always good. And so then it's going to ask you about your property. We are visiting Gotham Academy today on Earth 16 in Gotham City. It was built in 2014. It's 25,000 square feet. We have 5,000 feet of irrigation. It is 100% occupied. It does not show you the pictures though. It's a little upsetting. Next, it has a standard ID. So there are federal standards or state or local municipality standards that you can, they say there was so aggressive benchmarking laws. It sounds very aggressive, but basically they have their own standard or version of benchmarking that they accept as the minimum that you must do or perform. And so you can do this drop-down list or enter the ID, and it will sync your EnergyStar format with those standards. And then it's going to ask you about some questions about your property. Does the energy consumption include parking areas, i.e. a parking garage? Does it have a heated swimming pool? Or do 25% or more of the students attend school exclusively for preschool daycare, meaning that you're going to have a high occupancy load in the morning, but then in the afternoon it's going to taper off. And then, like I said, you're just going to fill it out. It's going to give you the profile of it, and then you're just going to walk through it. And so you're going to start inputting use. It's going to start asking you questions. So this is about parking use, whether you have open parking, surface or garage, how's it lit, what's the size of it, is there heating for it? Then it's just going to ask you about the property use. So like I said, we said high school, and like I said, most of them have a default value that you can assume, and then go in later and actually input your own, or just leave it as the default. And then there are Excel sheets. So this is one from EnergyStar. It's for inputting utility, using your utility data and billing data, and basically formatting it in Excel and then uploading it, and the program on the back end will parse it out and fill it into appropriate fields as necessary. The lab, we have one specifically for Idaho Power. So if you want to use that, it's a good way to analyze and get an understanding of it. And then you can also use that to upload various programs, and you just reformat it. And then so going over DDX, I did this slide early. So in addition to DDX, just being about the 2030 commitment and whatnot, they are encouraging firms who use the software to sign this letter, which basically says you will adhere to the 2030 commitment standards. You're going to try to do your best and do annual reporting and participate in the program. And I'm not entirely sure what this entails, but they also want a sustainability action plan. That's very broad and can include a lot of things. So if you're interested, look into that. And so we're going to shift back to data. So that's how you put a lot of the data and look at it. And now you want to know the analysis side of it, or how accurate your data is. So well, a level 1 energy audit is considered technically less accurate than a level 3. The overlap between all 3 levels are in big fish. So those are the most important that are using the most energy. So those should be consistent through level 1, 2, and 3. So you have to ask yourself, any changes that should occur will happen to the 35% in allocating or understanding where that energy is being consumed. So what that looks like is, so big fish being 65% in this example, everything else other being 35%. So using, again, your prior experience, like you understand buildings, what goes in the buildings is generally how things operate. So you're looking at lighting, HVAC, servers, refrigeration, depending on the size of the building. And then you should try to categorize the items into large to medium to impact based on quantity. So it has a large impact, it will have a medium impact, or this has a, usually you can fall in the margin of error, but because of how many there are on the building or being used for the building, it presents an issue. So let's say we did our first site visit, we got the data, we inputted the data, and this is what it's telling us. HVAC is using 15%, lighting is using 22, server room is 11, we have refrigeration at 6%, and then exterior lighting is at 9. So from there, we've identified the big fish into their respective categories. We want to use consumption to organize the energy plan to be most impactful. So we want to take a look at the lighting first, HVAC, server, exterior lighting, and then refrigeration. So what that means is we're going to look at doing a lighting upgrade with a new fixture, possibly LED, looking at the control system, how many occupancy sensors or photo control sensors we potentially add to that. And again, looking at the HVAC, do we need to add more set points? Do we need to redo the zoning scheme and plan, or Do you need to add, you know, a heat pump or a dedicated outdoor air system and revamp it, things of that nature. Servers are really hard to improve. They're kind of energy sinkholes by definition. So don't feel bad if you can't improve the server energy efficiency. They're not technically they're not designed to be efficient. They're just designed to work. Exterior lighting is always another good one. So upgrading to LED, having a lighting schedule, or installing an exterior photo cell that will basically just look at the time of day in regards to the lighting levels and decide when to turn on and turn off. So yeah, and then the other important thing to account for when you're proposing these upgrades or changes to your client is to account for incentives from the federal, state, and local utility level. That will definitely help your argument. And so once you do this, you have to reassess your plan though. And so you're like, well, Dylan, I already made a plan. Why am I making another one? You're not really making another one. So yes, you technically started making a plan when you collected data and you did the assessment, but now you're actually proposing the changes. And so now that plan changes based off of what your client is willing to do. And so from here, so say we have the energy, this is, you know, as it's performing right now, and we've miraculously convinced our client to do everything we've asked, because that always happens. And so this is the result of it. So HVAC got reduced from 15 to 10, lighting from 22 to 13. The servers we got some little more optimal performance for the scheduling, so 11 to 10, like I said, don't feel bad about that. Refrigeration, we didn't bother to touch. We'll go over that. Exterior lighting got reduced by 4%, 9 to 5. And then the other thing that tends to freak people out is other went from 35 to 56. So that's not a bad thing. Okay? That's just how the math works. So basically, you would say the big fish went from 65% to 44% overall for a reduction of 21% for this number of kilowatt hours or therms, BTUs, etc. So the way the math works is something has to use the most energy. Someone has to be the bad guy. So that's not necessarily a bad thing, but this is what informs next steps. So now you know how all these are performing and you're monitoring them. Hopefully you're annually inputting your data and doing a yearly annual benchmarking. Now you know in the future you're going to focus on this because it's the 56% now. And you're just going to keep doing this and keep doing this until you, in a utopia, you have the ultimate building that maximizes energy use. But essentially, that's where you're trying to head with this. But you don't feel bad if you don't get that. So here's why we ignore the 35%. So if you know that 35% and you know how it's allocated, how confident are you that you're going to be able to propose an energy efficient measure that is going to reduce the energy, but also be worth the payoff? You don't, but you're going to have to spend the time, energy, and resources doing that. So that's why we focused on the big fish. And then now the roles reverse, where the big fish is now the little fish, but it's known and defined. So now we can work on the other big fish. And sometimes, based off of your data analysis, you'll have a general understanding on what that the new 35% that became 56 is, and you'll know whether or not it could be worth it. And if it is, you'll know we're just going to focus on like the two categories for it. But say you did all that and you really want an accurate profile of how your building is performing completely. The ideal scenario is in mass. So when you're tracking multiple buildings. So you built a building and you're going to build it again. And you want to do it the same way. You want to use the same energy profile. But then it's not. You figure out why. And you can identify areas. So if you benchmark building B and you see that the lighting or HVAC is performing worse than building A, that's what everything else is nominal and within the appropriate range, then that's where you need to start and there's a problem. So basically large numbers is where that comes into play. So data analysis, now what? Again, what is your customer or client willing to do? I don't like to ask this question to a client or customer until I have my data, analyze the process. The reason is for how I consider framing a problem. So again, don't ask this question and because more likely than not, your client's not going to have a good answer for you. And part of the reason is that's why they're calling you, is they want to know the answer to this question. So personally, I don't like presenting a problem without having a solution or several viable solution options available to present, because then it's no longer really a problem, and you're not. It's more framing it in a neutral light. So you're not blaming anyone. You're not being deconstructive or saying, well, you know, the lighting's a problem, therefore it's this person's fault, and you're not going to get anywhere with that. So again, account for incentives. Incentives are important, and they do help you sell energy efficiency measures or upgrades. They also help, so when you do that, recalculate your payback period or your return on investment that you're presenting to your client, because that will help it. And having a smaller or shorter return on investment could help convince them to go with the strategy. And so the way we like to frame that is with this graphic, so taking impact versus cost. We really liked to be right here, high impact, low cost. So we're going to reduce a lot of energy, but it's not going to cost a lot. Those are great. We don't like to be here, where it's going to cost high and have a low impact. Usually you only do something that falls on that area of the graph if you're legally have to. Here's another area that's neither here nor there, high impact, high cost. So it's really situational, and whether or not you need to do it. Here's something that is kind of a good area. That's low impact and low cost. Typically these are low hanging fruit, or it's something you can present to a building or a client that they can do, and they can have tangible results, and they can see that this will have an effect on the performance, and so it can help them get them on board with other strategies now that they know, oh, hey, this actually works. This is the area of the graph where you want to look for incentives the most, because this is middle of the range. So either high impact with medium cost or medium impact with medium cost. And what we're trying to look for is trying to push it over to this area where the high impact and low cost. And how are you going to push it there? We're going to look at incentives. So here's the example we were talking about earlier. Here's where it falls. So our lighting upgrade is going to fall on this part of the graph. We have our energy management system, refrigeration, HVAC retrofit, lighting upgrade, and then a lighting schedule for the entirety of the building. So here's kind of where they fall on that graphic again. And so with incentives, again, and Idaho Power has incentives for every single one of these. There's a program manual over there if you want to take a peek at it and take it home and evaluate it. But lighting is one I'm most familiar with because I deal with daylighting, electrical lighting primarily. But this will take our lighting and shift the cost over to here because of incentives. And so now it's right on the border between high impact, low cost, high impact, medium cost, so we can start to make an argument for it to the building owner or the client on why they should do this, and that it's going to pay off faster than they think. It also allows us to start framing it as an investment, so we can tell about the payback return on investment that they're going to get. Typically, and here's how that, so the idea is try to push everything into the areas that you want, and you do that by finding the incentives. Let's see, how are we on time? I'm a little behind, sorry, I'm gonna skip over some things. So the other thing to frame it as an investment is to look at the non-energy benefits. So for example, if we're focusing on a lighting upgrade, some of the benefits that don't deal with energy from going from a compact fluorescent to LEDs are not needing to order so many bulbs for your lights to work. In addition, not having to schedule a lighting day out of the year or the month where you go and walk through the building and you bulb and rebulb all the fixtures. You also don't have to store them. You're not doing as much maintenance, so you're not paying someone to do that. There's also less interactions with that electrical system, therefore there's less risk of something dangerous happening. And in addition, increased security. If you have a lighting control system and you can monitor the kilowatt hour consumption for your lights in your building, it'll tell you when the lights come on after hours, and there's not supposed to be anyone in there. So you can investigate and figure out why the lights are coming on. There's a problem with the system, someone just worked late, or there's a new schedule change happening, and people are working on the weekend for the X amount of months, etc. But also, it improves the quality of light and allows you to adapt the space to your occupants, giving them granular control, increases the quality and how they feel and perceive the space, which allows them to be happy and more productive, hopefully. And it seems that we have a little bit of time. So framing impact versus cost. More often than not, your assessment reveals an issue. That's why you're doing it in the first place. I.e. the lighting system is consuming too much energy, high kilowatt hours. The example I gave, that I just gave was, replacing the T8 compacts with LEDs. Another thing is usually there are more compact fluorescents than are actually needed. It was overlit, so you can actually reduce that as well and have an opportunity to just reorganize the lighting plan as needed. But additionally, so say you do that upgrade, how you present it, you want to present it as a package option and then also break down that package and what comes into it. So let's say for that example, we're replacing the lights and there's an overall 65% reduction in our kilowatt hour consumption. Really great. But then we also want to present it to the client so they can understand it and figure out what they actually want to do is their building, their choice. So the LED is going to have a 40% impact. So probably not going to be hard to sell that. Probably going to want to be on board with that. Occupancy sensors. So adding occupancy sensors where code does not require it is going to give us 12%. Adding photo controls where code does not require it gives us 3%. And then implementing a lighting schedule to kind of control the exterior, interior, lights and offer flexibility, that's going to give us 10%. So you're probably going to have a pretty good chance of selling the lighting schedule and the occupancy sensors. Probably not going to be on board for photo controls. I love daylight. I wish every building was daylit, but I understand that it's not economically efficient or prudent to do it. So presenting that option and then, explaining to them that depending on the settings and how many of these they implement for the various control systems throughout the building, includes HVAC as well, will affect the performance. So, and it's also taking into account why post-occupancy evaluation is good, is the building occupants will change what you did. Not intentionally, that's just the way they are. And so you have to go in and evaluate that and consider that change. Is there a compromise that needs to be made, or do you just have to accept, they're not going to turn off the lights, or they're going to keep turning down the thermostat no matter what you do. So summary, facilitates energy accounting by comparing a building's energy use to similar buildings, or determine opportunities for improvements, or identify or quantify and verify energy efficiency measures. Identify underperforming buildings to target efficiency improvements. Identify best practices from efficient buildings. Set investment priorities. Verifying savings and prevent snapbacks. So if you can verify and prove to a client and they can see it happen, it decreases the likelihood they're going to go back to operating the building as it was. Earn recognition and implement a cohesive management program. And so that's all I have for you today. Thank you for coming. Any questions?
Yes. Thanks for your presentation. One question, CBEX data, thinking about benchmarking. One, challenge I have using that kind of stuff is just the question, are there multipliers or adjustments for our locality or any,
Yes.
anomalous conditions here in Boise, or, can you talk about that a little bit?
So the most common multiplier is climate. So depending on the climate zone you are, it will change. For comparing your building, because a building operating in our climate versus one operating in the East Coast is going to be completely different. So it could be a school, 5,000 square feet, same operating schedule, same equipment, but because of the climate, that's going to drastically change how you operate the building and where the set points are, where they need to be. So that's what the statistical algorithms do, is they try to bring that in line, because there are only so many buildings in one climate zone, so it's very limited. Not to mention that it's a voluntary program, so the data is then again limited on the availability of it. So that's why they have the algorithms applied so that you can more accurate. So this is, when I say score, it's not finite. It's an assessment, best guess. analysis of the performance of where you're at. So the only way you're gonna know for sure as an exact science is if you have the high performance building and you have smart metering on it, it's logging it you have all the monitors in place for CO2, temperature, lighting, everything like that. So you're just collecting all that data and processing it in real time. That's the only way you're gonna be able to be 100% certain on what your EUI of your building is. And so even then, like a building has an EnergyStar score, and 10 years later, that EnergyStar score could not be applicable. That's a snapshot or a slice of how the building is currently performing at that time. So that's why it's important to do it annually. So you get that data point, you can see the trend. Are we improving or are we not improving? And so we need to make some changes, upgrades. It's also indicators for maintenance, things going bad that need to be investigated or upgraded, things of that nature. Online?
Well, yeah, if I could just also follow up on that. CBEX does have the micro data that you can download. They keep promising when is the 22?
It's supposed to be October.
Supposed to be October. It was also supposed to be October last year. So
Well, it was supposed to be October, like January 2 years ago.
yeah. Eventually
We've
we'll
been
get
waiting for
updated
it.
data. The nice thing is that EnergyStar, and I'm assuming DDX does this as well, automatically filters it for that building type and climate zone and
Yes.
things like that.
You ever drop that
Within
menu?
CBEX, you can manually go in and filter it down, but like Dylan was saying, you quickly run out of other schools that are invoicing. They're not going to survey every single one, but you can find a couple of them and see how you're doing there. The data is anonymous, but still.
Yeah,
figure it
so
out.
in like certain cities, like off the top of my head, Boulder, Pittsburgh, and New York, they have very good benchmarking programs. Some of them, I believe in Pittsburgh and New York, it's required for you to report if you're a building owner. You have to report your energy use and submit the data and comply. And so it's anonymous though, but they have their own data sets for their area, and so you can reference that. And that's the intention for them is not to improve for energy efficiency, but more giving customers additional information and power when purchasing or renting a property, whether it's real estate or if you're commercial or residential. It's just another thing that they feel needs to be considered or disclosed upfront. We like it because it also gives us data, so we're all for it. Any other questions? Okay, thank you very much.